Good morning, grade 9s, and happy snow day. We're just going to finish up the note that we didn't finish yesterday. It shouldn't take us too long here. Okay, so we're going to change back and forth between a mixed and an improper fraction. Now, what is a mixed number? Well, this right here is a mixed number. It has a whole number out front and a fraction part there. It's called mixed because it has a whole number part and a fraction part, so it's mixed kinds. Okay, so what this actually means is I've got two whole objects and part of another one. So there's three identical objects right here, and the denominator tells us what each are split into. So they're each split into 1, 2, 3, 4 parts. Now, when we change it into an improper fraction tells us basically how many parts there are in total. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 quarter parts. Now the easiest way to do that is to say, well, I've got two wholes and they're each split into 4, so 2 times 4 pieces, and then I add the extra 3 pieces to get me to 11. And always the denominator tells you the size of the part. So there are 11 quarter pieces, meaning there are 11 quarters. Now, we don't want to have to draw this every single time. Luckily, it's pretty straightforward to get it just from looking at it. So we have two wholes. Each are split into quarters, so we do 2 times 4, and then we add the extra parts from here. So 2 times 4 plus 3. And of course, they're all quarters, so the denominator stays as quarters, and that gives us 11 quarters. So we're going to do an example here, and I've given you the numbers in this part, or not the numbers, sorry, the words in this part to be able to do the question every time. So for this first one, we do the whole times the part, so 5 times 3, plus a number on top. So I didn't leave a whole lot of room down here. You really should, for proper math form, it should follow this, and you should have one equal sign underneath the other. But for these examples, unfortunately, I didn't leave enough room. So 3 times 5 is 15, plus 2 is 17. So we have 17 thirds. This one over here, 10 times 4 is 40, and then I have to add the 9. So 10 times 4 plus 9, and it's still in parts of tenths. So that's going to be 49 tenths. This one here, 7 parts times 1 whole, so 7 times 1 plus the extra 3 means that we have 10 sevenths. So 10 of those 7th pieces. Now with this one, you have to be a little bit careful because there's a negative number out here, and basically all that means is that our final answer is going to be negative. Don't put the negative, don't do 6 times negative 5. Put the negative out front, and then you do 6 times 5 plus 1. If you do 6 times negative 5 plus 1, you're going to get the wrong answer because having a negative in there is going to mess up your calculation. This is saying that the whole thing is negative, which includes the 1/6 as well. And of course, we have a 6 here. So negative, the whole thing is negative, and then we just do the rest as it's normal. So 30 plus 1 is 31/6. Now going back the other direction from a improper fraction to a mixed number is a little bit harder. And I do want to just comment at this time that I really wish they hadn't called them improper fractions, because having the number on top bigger than the bottom really isn't a problem. And in a lot of things that we're going to do, we would rather have them as an improper fraction than a mixed number to start with. So it's not, improper is kind of a misnomer there. Anyway, we're going to go back the other direction. So converting an improper to a mixed. So you're going to use your calculator to change it into a decimal to start with. So when we plug that into the calculator and do 45 divided by 7, we get 6.42857. All we're really interested in at this point is the 6 on top. So we've got the 6 on top, or the 6 is our whole number. So we take that 6 and we put it out front. Now we have to figure out what goes here. Well, I know that 6 times 7, so if I'm basically starting this process, 6 times 7 plus this has to give us 45. Well, 6 times 7 is 42. So to get to 45, I need 3 more. And so basically we did 45 take away 42 to figure out that we need to put a 3 in there. And you're going to do that every time. So here we go again. We'll do a few of these. So 18 divided by 5. So we'll go 18 divided by 5. The only thing I want from here is the 3. So that gives us 3.6. I just want the 3. Now I'm going to do a quick calculation here. 5 times 3 is actually 15. So to get to the 18, I have to do 18 minus 15, which is 3. Now that tells me how many bits I have left over up here. So it's 3/5. Over here, 11 into 28. You can do that on your calculator. Hopefully you don't have to. 11 times 1 is 11. 11 times 2 is 22. 11 times 3 is 33. So 3 is too big. So that's 11 times 2. And I know that 11 times 2 equals 22. So I need another 6 to get up here. So 6/11. And you could write that down. You can do the 28 minus 22 if you want. But I don't need to see all of this all the time. Sometimes it's possible to do stuff in your head, and I don't need to see all the work shown. Sometimes I might ask you for this work shown, though, so make sure that you understand it. This one, let's pull the calculator back over. 120 divided by 15 is 8. There's nothing left to put on that. 35 divided by 7 is 5. There's nothing more to put on that one either. Now you can put 0/15 if you want, 0/7 if you want, to show that there's no extra coming up there. But otherwise, these are just straight up whole numbers. And normally we don't do this. So I'm just going to erase that. What do we have next? Oh, I have a blank page next. So I guess we're done. Okay. Enjoy your snow day, everybody. And please complete the homework for these questions.